In this video, we are going to just do a brief introduction for vectors. And so with vectors, the first question is, what even is a vector, right? What is it? And the good news is that the definition is super simple. So a vector is just a quantity that has magnitude and direction. Okay? And so if you've never heard that before, then maybe that might not sound as simple as I'm saying it is, but it really is quite simple. So by magnitude, we just mean that there's a number attached to it. All right, so for example, if we're talking about speed, 55 miles per hour, for example, that is a magnitude, right? And a direction would be something like south, right? So 55 miles per hour south is a vector. Now, south by itself is not a vector, it's just a direction, right? And the same thing over here, 55 miles per hour, that's not a vector, that's just a speed, right? And so, but you put those two together, right? You combine them together. I'll actually draw it like this, right? You pull them together and you get something called velocity, if I could spell, right? So you get velocity. Okay, and so velocity is a vector. And so that's really the litmus test for all vectors is, does the thing that we're talking about have a magnitude? If so, does it also have a direction? And if it has both of those things, then it is a vector. And so the question is, well, why do we, why use vectors, right? What's the big deal? And the big deal about vectors is because, is that by having a magnitude and a direction, we actually have a lot of information contained in just one thing, right? In just one velocity, for example, that's a lot of information. And physics cares a lot about which direction things are going. So if we're in three-dimensional space and you got the x direction, y direction, and the z direction, x, y, and z in three-dimensional space, then it really matters, that if somebody is going, let's just say that this is the velocity vector that somebody's going at. And I know it's really hard to see, but let's just say that that's in the positive y direction, positive x direction, and then negative z direction. And that's where that velocity vector is pointing. So positive x, positive y, negative z. Well, by having a vector, that, like I said, that contains a lot of information, more than just somebody going 55 miles per hour, right? That's very little information. And by holding on to all of that information, it allows us to do more complicated problems, okay? So a scalar, on the other hand, what's a scalar? Well, if we're going to talk about vectors, we have to talk about scalars. A scalar is just a number, okay? And that's essentially that magnitude part. It's very much the same thing, okay? So a scalar is something like temperature, right? Temperature, you could say mass. As we said, speed without a direction, speed plus direction is velocity. That's a vector. Speed without a direction is just a scalar, not a vector. All right, and then maybe something like energy. So these are examples of scalars. And so I'll give an example here. So say that we take the word temperature, and let's just say that we don't know it's a scalar, but we want to figure out if it's a scalar or a vector. Right, scalar or vector. The real trick here is to ask something like this. Can I assign a direction to this quantity? Right, so can I draw an arrow to describe the quantity in question, or can I only draw a dot? So can I draw an arrow to describe this thing, or just a dot? Okay, can I draw an arrow to describe this thing, or only a dot? So let's put that into practice. With temperature, let's just say that we have a room. And in this room, I pick one random spot, right? Let's just some random spot, right? And that's the one we're talking about right there. Now, let's just say the temperature here is 70 degrees Fahrenheit. Okay. It does not make sense to draw this dot with an arrow, right? Temperature doesn't move, right? There might be an airflow, but there's no movement of the actual temperature thing, right? That would be very strange. We don't really think about that intuitively. That's not, or I should say intuitively, that should make sense, right? This is not some temperature arrow, right? There's just the temperature at that point. The temperature right next to it at this point, it's probably very close, but it's not guaranteed to be the exact same. You know, you pick any point in the room, these are all not guaranteed to have the same temperature. They might be very, very close, right? And they should be very close statistically, but they're not going to be the same. And you're not going to draw arrows in all these little temperatures, right? Because temperature is not something that moves. Particles move, but particles are not the same as temperature, right? That doesn't make any sense. And so because drawing those arrows doesn't make any sense, that's a really good indication. And it's not a foolproof way. You know, I'm sure that somebody could come up with some sort of scenario where it doesn't make so much sense to do it this way. But I would say the vast majority of the time, this is a great test, right? Can you draw an arrow to describe that thing, or just a dot? In the case of temperature, it's only a dot. Now, let's say you have a box, and you want to describe the mass of the box. Well, rather than drawing a box at that point, we might just draw a dot, and we might say mass equals 5 kilograms. Okay, it doesn't make sense to draw an arrow, right? The mass, it might be moving, but that would describe a velocity, right? If we drew an arrow attached to it, that would be a velocity. It doesn't make sense to draw an arrow itself to describe the mass of something, right? Now, this is what I was actually getting to is something with speed. You might want to draw an arrow there, right? And this is why this way is not perfect, but you know, you might want to draw an arrow with speed, but that would be speed plus direction. Speed is actually the dot itself. And so speed is the dot, and the arrow is the direction. And this gives us velocity. Okay, so like I said, it's not perfect 100% of the time, but it gives you a great idea. One more example, let's do energy. This is one that, again, it makes intuitive sense. You don't draw energy with an arrow attached to it. I mean, if you were trying to draw a diagram with some energy, you wouldn't really draw an arrow attached to it. That doesn't really make much sense. You might be trying to describe an energy flow, but the energy at a point is something like, let's just say 10 joules of energy at this point, you know, relative to something else. And so you wouldn't draw an arrow there. Okay. So that gives you kind of an introduction there to some more scalars. Well, let's just talk about some vectors for a second. So what are some more examples of vectors? So force is a good one. All forces are vectors. Momentum is a vector, right? And why is momentum a vector? Well, you might not have learned this yet if you're just getting started with physics, but we'll say P, momentum, is equal to mass times velocity. And then we draw these little arrows above them to let them know, or to remind us that these quantities are vectors, right? So we said mass is not a vector, so it's not going to get an arrow on top of it. But then momentum and velocity are vectors. So if you take a scalar and you multiply that scalar into a vector, you're going to get another vector, right? And that's one of the rules of vector multiplication. When you multiply a vector by a scalar, you get back another vector, okay? And so obviously then we can just go ahead and write velocity on our list one more time. We've already said that many times. And let's just write acceleration as well. Okay, so four examples of vectors right there. And so just to really, I guess to kind of hound on the same point one more time, if you say, I'm driving in a car down the highway, or say, for example, you are driving in this car down the highway and you're on the phone and you say the words, I'm going 65 miles per hour, right? You have just described that dot for speed. Speed equals 65 miles per hour. But if you say on the phone instead, I'm going north at 65 miles per hour, north at a speed, 65 miles per hour, then you have described a vector, and that is velocity, right? Specifically, you have described the velocity vector. Okay. And so that is just a really brief introduction to vectors. And in the next video, we'll take a look at some more introductory physics topics, especially the position, velocity, and acceleration versus time graphs.